Hello students, welcome to Sources classes. Today we'll be solving the ISI Mmath question paper of year 2016. Today we'll be solving question number 22 from the paper. Now before beginning question number 22, I'll say you about the solutions for question number 19, question number 20 and question number 21. As you know that we have already solved the ISI Mstat question paper for year 2016, and these very questions, question number 19, question number 20 and question number 22, have come in the ISI Mstat question paper of year 2016. I'll be mentioning you the corresponding question numbers for each of these three questions, and you can check the solutions to those questions for the relevant process and methodology. For question number 19, you can see question number 5 from the ISI Mstat paper. For question number 20, refer to question number 25, and for question number 21, refer to question number 21 from the ISI Mstat paper of 2016. So now let's shift our focus to question number 22. In question number 22, we have been asked to find out the range of A for which the infinite series summation of a to the power n into log of n upon n square, where n tends from 1 to infinity, converges. The range of A is given as A belongs to minus 1 to 1. A belongs to minus 1 to 1. These are the different ranges. And the last option is A belongs to minus infinity to infinity. These are the options that we are looking for here. So what we'll do over here is that the series that we have been given is summation of an log of n upon n square, where n goes from 1 to infinity. We'll use the ratio test over here. For the ratio test, we'll find out the ratio of un by un plus 1. This will be equal to a to the power n log of n upon n square into a to the power n plus 1 into log of n plus 1, and in the numerator there will be a n plus 1 whole square. Now if we take n plus 1 in the square, this will come down to 1 into 1 plus n whole square, okay? And taking a common, this will be equal to 1 by a, and this will be equal to log of n upon log of n plus 1. So these are the three parts. So if we take limit n tends to infinity un upon un plus 1, then this will be equal to 1 by a, because this tends to 0 and also this cancels out. This will be equal to 1. This will be equal to 1, not 0. This will be equal to 1. It is also equal to 1. So ultimately this comes down to this value, and we have to put a mod over here. Now since summation of un converges, this implies that limit un upon un plus 1 for n tends to infinity is greater than 1. So this implies that mod of 1 by a is greater than 1. This implies that 1 by mod of a is greater than 1. This implies that mod of a is less than 1, and this implies that a lies between 1 and minus 1. This is one interval that we have found out. Now we have to check out at a equal to 1. At a equal to 1, un is equal to log of n by summation of un will be equal to summation of log n upon n square, and which is always convergent. Convergent always. Similarly, at a equal to -1, summation of un will be given by summation of -1 to the power n log of n upon n square. This is also convergent always. So we see that for a lying in the interval -1 and 1 and a equal to 1 and a equal to -1, the series is convergent. So the new range will be -1 equal to less than equal to a less than equal to 1. So a belongs to the closed interval -1 to 1, which is the option C. So today we have solved question number 22 from the ISI Mmath paper of year 2016. We'll be solving the next questions in the subsequent videos. Thank you very much.